So, question 123. It's not quite as easy as 123, this question. A couple of overlapping circles. Let's see how we get on. So, to help me to make sense of this question, I'm going to add a few lines to the diagram and a few measurements, in fact, all the measurements that we've been given. So, there are two radii from the smaller circle here and here, they're both length 2. The radii from the large circle here and here, and the length of the line between the 2 points of intersection, length of 2. So this smaller triangle is clearly equilateral, so we can state immediately that the angle there is pi over 3. Radians, of course. Now we'd like to also find this angle here. So what I'm going to do is I'm going to split this larger triangle into two right-angled triangles. And I'm going to find this angle here and then multiply it by 2 to give me this angle here. So we've got 2 times the arc sine of 1 over 3. 1 because that length is 1 and this is 3 here. So we've got both of the angles subtended by the triangles at the centres. And then we can work out the area of the large segment. And the large segment is this one here. So that's the segment from this centre here. So it's a half r squared times theta minus sine theta, r being 2. So it's a half r squared. Theta is pi over 3 minus the sine of theta, the sine of pi over 3. So this gives me an area, and I've put that to 4 significant figures for the moment. And then the area of the small segment, this segment here, is part of that sector. So once again, a half r squared theta minus sine theta, and I've been careful to use the unrounded version of that number in these calculations. Although I've only written 0.680, I've actually used the unrounded number so that this number here is correct to 4 significant figures. So then when I find the area common to both circles, I can confidently add those two numbers together and get my correct answer rounded properly to 3 decimal places or 3 significant figures, whichever you prefer.